Determine all critical numbers for the function f of x equals the square root of x squared plus 24 divided by x minus 8. Critical numbers are the x values that make the numerator and the denominator of the derivative equal to 0 and are in the domain of the function. The first thing to do is find the domain. F of x equals the square root of x squared plus 24 divided by x minus 8. We can rewrite the square root as a fractional exponent. It will be x squared plus 24 to the first power second root, 1/2 power, divided by the x minus 8. So the function is made up of an even root. The denominator of a fractional exponent is the root. It's an even number here, as well as a denominator. For the domain, what's inside an even root has to stay greater than or equal to 0. So x squared plus 24 needs to stay greater than or equal to 0. And what's in the denominator cannot equal 0, so x minus 8 cannot equal 0. Those are the conditions necessary for the domain. Starting with the x squared plus 24, let's subtract 24 from both sides. So x squared is greater than or equal to negative 24. We can then take the square root of both sides, so the square root of x squared is greater than or equal to the square root of negative 24. The square root of x squared is the absolute value of x. The square root of negative 24, being that it's negative and it's an even root, it's not a real number. And since it's being compared against something that is not a real number, this condition will not be needed and will not affect the domain in any way. Working with the x minus 8, we can add 8 to both sides, and x cannot equal to 8. So that will be the only condition on the domain. The domain will be all real numbers except for positive 8. So the domain will start at negative infinity, go up to positive 8. It will not include it, so round bracket on the 8. Union, it will start back up at 8 again, but not including round bracket. And all the way to positive infinity. So that domain is all real numbers except for positive 8. The next thing to do is find the derivative. We have a quotient here, so we'll make use of the quotient rule. The derivative of the numerator is a power rule. Bring the power down, leave the inside alone. Subtract 1 from the power, I will call it 2/2. Multiply by the derivative of the inside to complete the chain rule. And then times the denominator left alone minus the numerator left alone times the derivative of the denominator, which is a 1. And the entire thing over the denominator squared. For the first term in the numerator, we can collect together the constants. Everything's multiplying each other here, so we can put those together. 1/2 times 2 is 2/2, or 1. There's also an x and an x minus 8 that can move to the front of it. And an x squared plus 24, that'll be to the 1 minus 2 negative 1/2 power. The second term is 1 times that negative expression, and 1 times anything is itself, so it'll just be the negative expression of x squared plus 24 to the 1/2 power. And all of this is over x minus 8 squared. first term in the numerator has an expression that is a negative power, it can move to the denominator of the first term to become a positive power. The x and the x minus 8 will stay in the numerator. And the x squared plus 24 will move to the denominator to become a positive 1/2 power. Since one of the terms in the numerator is a fraction, we will need to get a common denominator between all terms in the numerator so that we can combine them over that common denominator. So the other term in the numerator needs to be put over that same denominator. We will do this by multiplying it by x squared plus 24 to the 1/2 over itself, a form of 1, so we do not change the value, just the look. But it will give it the common denominator so that we can combine those terms together. The numerator of the first term, we can distribute that x in, so that will be x squared minus 8x. The numerator of the second term is negative of the quantity to the 1/2 times itself. Since they have the same base, we can add the exponents. 1/2 plus 1/2 is 2/2, their first power, so it'll be x squared plus 24 to the first power, but there is a negative in front of it, so it'll stay in parentheses until we distribute the negative in. All this is over their common denominator of x squared plus 24 to the 1/2 power. And then the entire thing is over the overall denominator of x minus 8, quantity squared. So we have x squared minus 8x, and we can distribute the minus sign here, which will be a minus x squared and a minus 24 all over. And 1/2 power can be rewritten as square root. In the numerator, like terms can be combined, the x squareds will cancel each other out. And since we have a fraction in the numerator, we can take the fraction in the denominator. It's not a fraction just yet, but it can be made a fraction by putting it over 1. And we can reciprocate it and multiply it with the numerator fraction. So we would have negative 8x minus 24 over the square root of x squared plus 24, and it will be multiplied with the reciprocal of the denominator, so 1 over the x minus 8 squared. So the derivative is equal to multiplying the numerators. Anything times 1 is itself, so it'll be the negative 8x minus 24. And then multiplying the denominators, there's the square root of x squared plus 24, and then the x minus 8 squared. So we've put the derivative into a single fraction. All powers are positive, so we can now set the numerator equal to 0 and the denominator equal to 0 and solve for all x's to make it true. Starting with the numerator, negative 8x minus 24 equals 0. The first thing to do is add 24 to both sides, so negative 8x equals a positive 24, and then divide both sides by negative 8. Positive over negative will be negative, and 24 over 8 is a 3. Working with the denominator, we have the square root of x squared plus 24 times x minus 8 squared equals 0. Since the product equaling to 0, we can write each portion of the product equal to 0 separately and work with each of them separately. Starting with the square root of x squared plus 24, we can square both sides. Square root squared cancel each other out, and it'll be x squared plus 24 equals 0 squared, which is 0. We can now subtract 24 from both sides, and then take the square root of both sides, which will give plus or minus the square root of negative 24. Since again we have an even root of a negative number, this will not be a real number. It will not be one of our critical numbers. Now working with the x minus 8 quantity squared equals 0, we can take the square root of both sides. Square root of x minus 8 squared will be x minus 8. The square root of 0 is 0. We can add 8 to both sides, and x equals 8. We will now check to see which of these will be in the domain. The domain is all real numbers except for 8. So negative 3 is a real number, but it's not an 8. And we can't have the not real result, so we can cross that out. And x is not allowed to be an 8 in the domain, so we can cross x equals 8 out. And it looks like we have one critical number for the function, and it is x equals negative 3.